Hello everyone. In this class, we will discuss another numerical on Mohr circle while application of force is in tensile and compressive direction. So, here you can see the force applying in x axis, that is tensile in nature. So, it is tensile force, and here you can see the y axis force is compressive in nature. We have already learned that if the force acting in tensile direction, we will take the tensile direction as positive and compressive as negative, right? So, here we have two forces and the angle acting in anti-clockwise direction. We have already discussed what we do in clockwise direction and anti-clockwise direction. So, here we have tensile and compressive, positive and negative signs. Okay. So, now our work is to find out normal and tangential stress in this case. So, how we will solve this numerical? First, what are the given data? We have sigma x, that is 100 megapascal, and sigma y as 50 megapascal. Okay. So, to draw the Mohr circle, we need what? X axis and y axis. Here we have x axis and y axis. Okay. Right. So, let us take this as our x. We have already known that for normal stress, we use x axis, and for tangential stress, that is tau, we use an y axis, right. So, what are the next things we need to draw? Okay. So, now our work is to, let's just extend this line up to this point. Okay. We have known already what are the sigma x and sigma y things. So, let's draw it properly and just learn what are the different things we need here in case of positive and negative sign. Okay. So, you will understand better why we extend this line. Okay. Little bit you can remember that sigma is in positive and negative both direction. So, that we use in both direction. Here we will take 0, this is our plus 1, and here we will have minus 1. Likewise, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 up to 10, and here up to 5. Okay. So, let us take this 100 megapascal as 10 centimeter or 10 mm you can take, or 10 unit you can write. Okay. And 50 megapascal as 5 unit. Okay. So, here you can see this 100 megapascal is nothing but what? In tensile direction. So, up to this is what? Sigma x. And from this to this, here we are having sigma y, that is 50 megapascal. Remember, like Here we are having the compressive stress. That's why we extend the line and draw the y-axis here. Next what? We need to calculate sigma x upon sigma y. We have already done this process. That is 100 plus 50 upon 2. We are having 75. Okay. So, let's from this to this, the center of the diagram will be here. Right. Next, what we will draw? We just draw the Mohr circle. I think here it will be very big. Okay. So, the Mohr circle is going to be very big, but as it will be easy that the angle is in anti-clockwise direction. If angle is in clockwise direction, we need to draw the diagram below the axis. Okay. Now what? We are having the center point here. So let's take it as M. We are having 30-degree angle. So in case of Mohr circle, we will take that as 30 degree into 2, that will be 60 degree. So first we will draw the axis up to here and take this point as P. Let it as P. Okay. So from point P to x axis, we will draw one perpendicular here. Okay. Now this is perpendicular from P to this, and it will be, let's take it as N. So Pn we have, that is our shear stress. Okay. From here, this to this, we will take the shear stress, that is tau. And next what we will draw? We need to draw this from this to this here. This is nothing but our sigma n. So sigma n will be 1, 2, 3, 4, 5, 6, 7. Let it is 70 megapascal. Okay. And tau, let tau is equals to 45 megapascal. Okay. Now our work is to find the resultant stress. Resultant stress will be nothing but what? Sigma r is equal to what? Sigma n square plus sigma t square root over. Okay. So we have the sigma n value and we have tau value. So also by analytical method, or we can use the Pythagoras method from this to this and find out sigma r. Also we can draw the resultant stress like this. Okay. And what? The base is nothing but sigma n and the height is nothing but our tau. So here by measuring the value OP, we will have sigma r. Okay. So in this case, our work is to find out what? Resultant stress, normal stress and tangential stress. By using this method, we can use it. So if in case this is not anti-clockwise, it will be clockwise. So what do we need to do? Okay. Here we will draw this Mohr circle and what? Our angle will be in this manner, like this. In case of if the direction is clockwise. Okay. It will be your 60° and you will draw the perpendicular from this. Okay. You will draw the perpendicular like this and we'll have the values again. This will be your sigma. What? This will be your sigma t and you will have the sigma t in negative sign. Okay. Here. And from this perpendicular to this you can have sigma n. And you have sigma r, that is sigma n plus sigma t of sigma n square plus sigma t square root over. Okay. So there will be not very large changes, but minimum changes we need to remember these things. Like if there will be compressive and tensile stresses, we just need to draw this diagram. Okay. Another thing is what? If these 100 megapascal is in compressive direction, so what we need to do? We need to extend this line like in this manner and extend up to 100. Okay, and the circle will be this 5 to 1 and here. Here will be the center of the circle. The Mohr circle will be like this. Okay, so what are the changes? There will be angle will be between, sorry, here we will have 60°. Okay, so this is going to be your tau and here from this you will have up to O, you will have sigma n. Okay, the tau will be constant, or you can say the tau will be no change. There will be no change in case of find out tau, but sigma n value changes. Okay, so in this class you have learned what are the different forces and how we use in case of Mohr circle these compressive stresses and tensile stresses, and by putting those values how to draw Mohr circle. So in this class we have learned these things. So in our next class we will solve lots of numerical on base of Mohr circle. So till then keep smiling and keep shining. Thank you so much.